Thank you very much, Christian, and hello everybody. Thanks for listening in, and of course, lots of thanks to our organizers. Firstly, for bringing the ACES at home to the world. Really a great initiative. So let me start. Yeah, as you can see from my title screen, I'm obviously located in Switzerland, and that's where I'm sending this message to you, basically, which is the message about that the autonomous database, the Oracle Autonomous Database, plays very well with data lakes. And not only on premises, but also in the cloud. And we'll see how that goes, what is the means to have them work together. And we will have some cloud demo later on also. So first of all, what's our agenda? Short introduction, and then we're talking about first a little history, which I would call a data puddle, and then about real data lakes, and then we go to the cloud and see how the current service offering of Oracle works together with the data lake. Okay, so let's start off. Just a quick introduction where I'm from. I'm from Sun IT. We're, as said, a Swiss consulting and implementation services shop for data warehousing, big data, EI, and analytics. So no OLTP here. We're focused on Oracle on premises, Oracle only. In the cloud, it's Oracle. And if the customer really doesn't want to do anything with an Oracle database or with the Oracle cloud, we would also could help you with Snowflake in the other clouds. Serving a wide area of industries, have quite a number of specializations. And our motto since 20 years already, before it was fashionable to talk about it, was get value from data. So, and me, I'm a computer scientist by education with a PhD in robotics and machine learning. And I'm working with database technology for about 25 years now, I guess. Meanwhile, doing data integration and warehousing, but also analytics and BI. And I've been the CTO of the Sun IT company, and now I'm also the CEO of the company since a few months. And I'm an Oracle ace, like everyone presenting here, I guess. Now let's jump into the topic. A data lake. And here I thought, first of all, let's look at the data lake definition that we can find on Wikipedia. So they say a database lake is simply a repository of data. All right, there are many of those. And it's materialized basically in files. Okay, that's not new either. But those files are stored in their natural raw format. So whenever data is produced in a certain format, it's stored in its raw format in the data lake. All of the rest of the text is more or less just giving more details, right? So basically, a data lake is a data repository where raw format data is lying around, represented in files. Okay, that doesn't sound so new, does it? So basically, we had sort of data lakes forever, I guess, because data has been coming along in files for years and years and years, at least as long as I'm in the industry. I mean, there are applications that have direct connections and write into databases, for example, directly, but lots of the data, especially in warehousing, has always been coming in files, okay? Only those file systems that the stuff was stored on were much smaller. So basically, nobody would keep the stuff around for very long because that was expensive. Moreover, getting to the data was kind of hard because the networking was very slow. So you would also want to bring it directly to the point of processing as quickly as possible. And what we did, up until quite recently, I would say, would basically use something like the SQL loader from Oracle to get to our, what I would call now data puddle, our landing zone or our file system where some stuff was delivered to. and load it into the database. Because this was hard work and took a long time, especially through because of networking constraints. So you wouldn't want to do it constantly, but just once. So basically, you were loading the data into a database of sorts, in our case, in a relational Oracle database, to process it there, right? For good technical reasons. And that, by the way, was the case for half of Oracle's history, right? So Oracle is about 40 years old, and that was the way you would do it with a SQL loader, or if you would get a dump file with something with import export or whatever, but you would use these tools for 20 of the 40 years of Oracle's history. And basically that would give you, for data warehousing, this architecture, which is an old 15, 20-year-old screenshot from Oracle, basically, where you have some sources and you process the data through a number of architectural layers up on the right to your analytics. But all of these layers in this red square, they are all inside the database, right? So we transport everything in there once, and then you would throw the files away, since disks and disk storage was also very expensive, especially managed disk storage, and you would keep everything just once in the database. And then there came, after 20 years, there came the big improvement in the Oracle database, which were external tables. So now you could basically define a table in the database with its structure and also lots of stuff on it, and could apply all the security models that you have to it, but it wouldn't store the data inside the database, inside its data files in a parsed and optimized format. No, it would leave it where it was, and it could read from there. Okay, so you'd have metadata in the database, and you leave the data outside in your data puddle, or however, on your file system, however you would want to call it. And that was basically with 9i, and that was at the turn of the millennium, after 20 years of Oracle. With 10G, then we got write back, so we could also write on these things, into these files. And with 11.2, then finally we got also inline pre-processing, so that we could start some scripts that would run and pre-process the data from its raw format, if it came in a raw format, into something that the database would be able to handle. Like, for example, unzipping it and stuff, right? So now, suddenly, with this pre-processing, loading, parsing, and processing the data, all of that happened when we select something, and not just the selecting part, because we have to first get it from the files. That sounds pretty much like the data lake, doesn't it? So Oracle was pretty far ahead of its time at the turn of the millennium, really. And then this started. In 2006, Google came up and said, well, now we have huge amounts of data, and we need to do that efficiently, to process it efficiently. So that's nothing for a relational database. We'll run our Java programs on top of it. And yeah, since the hardware development made machines so much faster and disks so much cheaper, we're going just to leave it lying around on disks, and we do big data. So we get lots of storage, lots of disks, and we run our programs on top of it. And basically that was the beginning of the real data lake, from a puddle to the lake, because now the paradigm suddenly was, we don't throw anything away anymore. So you can leave it there and go to it whenever you want. You can go back to your raw data whenever you want. But the funny is, because the networking technology apparently was still not that far, Google went for, I think was a very good idea. They went for a shared nothing architecture. So the storage layer, not like a mounted file system or whatever, was shared among compute nodes. No, it's basically the Teradata without the relational in it. We have compute nodes with direct attached disks, and we have a compute layer, and we have a distributed, at least a distributed file system. Okay, so it can do massively parallel and scalable with a cheap storage at hand. And this whole thing is basically a divide and conquer machine, okay? What also came with this, of course, was that people said, no, these old relational databases, that's bullshit. We don't need that anymore, since now we can go back to the raw data whenever we want, and we can program Java or whatever on top of it. We don't need this commercial, expensive relational hogs. And by the way, this whole relational model is so old and so retro. No, we're doing new stuff, and everybody wanted to do NoSQL with JSON documents and hierarchies of documents, and basically reinventing the document database, focused databases of the 60s, and starting a new cycle there. But that's the Hadoop world. That's the real data lake world. And with all of that, of course, there were scores of new tools and file formats like Avro, like Parquet for column-based storage, whatever, new players in the market. And of course, that brought a big boost to IT in general, to data processing, and so on and so on. But suddenly at a certain point, people found out, well, lots and lots and lots of the data that we store in data lakes is not unstructured, like the marketing always tells us. Lots of it is really, really structured, or at least semi-structured, but most of it is really structured data. And structured data, and we don't only want to have it shown in a web service or web front end where a document format might be a good idea. No, we want to use it flexibly. So what was that again? There was this relational model to do these kinds of things. And so in the end, people found out, yeah, having SQL on top of a data lake is a great thing. And so Google started building the BigQuery service and whatnot, and everybody started thinking about having either just a SQL API on their favorite tool, or really connect classic relational database management systems to that data lake in order to have all the benefits of the relational world. And that's what Oracle also did. They made Hadoop accessible to the database, okay, by furthermore enhancing the external tables. And there were the Hadoop connectors, which basically now allow to define external tables in the database, but not against the file system, but against a Hadoop cluster with its HDFS file system, such that the database would call the Hadoop cluster and say, please deliver these files contents to me. And in order to make it a little more easy, it was also, those Hadoop connectors also were able to talk to the Hive metadata layer on top of a Hadoop cluster, which made it much easier to define the structures and everything. So, but with this, we could really draw data from this data lake with external tables. And all the processing happened in the database as it was before. Now, all of this is on premises, right? And then in 2016, 17, that's not that long ago, Oracle extended external tables again and basically introduced partitioning for external tables. So now the database can't find out by itself what is in what file. So you have to basically define which files belong to which partition of your data or to which subpartitions. But then, once the database does know, or through Hive knows, the database is capable of only asking for the files it needs to do a certain processing job. So if you have partitioning and your filtering criterion is using the partitioning criterion, hey, you only read the files that you need. So basically you can significantly reduce IO from terabytes down to megabytes, maybe, right? And that's really cool. So that's been a real breakthrough for working with a database directly on the data lake. And it's not that long ago. So with this, the database was really made data lake ready on premises. And of course, I'm always talking about IO and how to access stuff and things like that, and maybe also save time by doing that. You have a much faster time to market for your business customers if you can build an external table and can give them immediate access through their BI tools or whatever, through the SQL interface. That's cool, but let's not forget one very important thing, which always has been a problem on data lakes, is security. So security on Hadoop clusters has been sort of a nightmare for many. But if you go through an Oracle database onto the data lake through external tables, you can apply all the security mechanisms that the Oracle database has had been for years and decades. So you can really secure the access to your data lake using the Oracle database with external tables. Okay, and now there's something that is especially for on-premises. Oracle came to the idea and said, well, you know, still we have to get all the data, even with partitioning, into the database that we might need, and then we have to do all the processing there. Couldn't we push down part of the computation to the Hadoop cluster itself, to the data lake, basically, to its compute layer of the data lake? And therefore, they further enhanced external tables to work together with the big data SQL software from Oracle that you could install on the Hadoop cluster, and which is really the Exadata storage cell software, just altered and enhanced for this purpose. Now, you can define external tables that, when you select from them, are pushing a request down to the Oracle Big Data SQL software, which then gets the data from the HDFS, or again via Hive, or even from Kafka messaging services, or from NoSQL databases, and delivers it back to the database. And it not only delivers back the data to the database, it also pre-computes results, if possible, on those nodes. It's really working like an Exadata, just with a Hadoop cluster. And so we can have now SQL push down to Hadoop clusters, all through external tables and the use of Oracle Big Data SQL. And that's, of course, a tremendous improvement in speed and performance in accessing this stuff. So, right, data lakes work great together with the Oracle database, especially as we see now on premises. But then, okay, just one more thing here. Basically, this leads to an adapted information management architecture. We don't do everything in the database anymore. We leave the data in our raw data reservoir, which is the data lake. And then we build a foundation layer for a data warehouse, for example. I would say in a relational database management system, Hadoop aficionados would say, no, we are computing that foundation layer with, let's say, a Spark, and then write it back to the data lake. Well, and then you build access structures, the data mart layer, most likely in a database. So there was a change in the way things are done. And then this happened, the cloud. Suddenly, there were those few hyperscalers that are on the planet, and they told everybody, hey, we can virtualize infrastructure, and we can give you infrastructure platforms and software as a service, and we can automate all of that. So it gets much cheaper to do all of these, everything basically. And we can give you very cheap, reliable, fast storage, object storage. And that's basically now, that means you can go back from what Hadoop did, go to shared nothing. You can go back to sort of a shared disk or a shared storage architecture, because networking now is so fast that you can have your data lake. You don't have to split it up on many nodes and then also split up the workload to go on in a divide and conquer strategy to go on those nodes and work directly on the storage. No, you can basically access all of your data lake through one interface. And then you can now arbitrarily parallelize on top of that in your compute layer. So that's a big difference to Hadoop, but still the data lake notion is there. So is that the death of Hadoop? If we look here at 12 years of search data from Google, we see that the green line, the cloud, had a big bump in the beginning of the 2011, then everybody knew what it was about, but it has a steady interest. Data lakes are going up in interest, and it's a very specific term, so there aren't that many people looking for it, but it's going up. Data lakes are in fashion. Big data is in fashion, and it stays in fashion, the blue line as we see, but the red one, Hadoop, that's basically on its way down. Their interest is lost, and I think it's on the way out of the door, except for a few big companies that will stay with on-premises Hadoop clusters. Everybody else that will do big data will do so in the cloud sooner or later. So this cloud thing is really, really important. More important now than the data lake on premises on Hadoop, I would say. But the first thing that the big hyperscalers did when they talked about cloud data lake architectures was basically just like on premises, only a little bit different. You use the same tools like on premises, the Hadoop tools. We see the elephant in the room here and on the picture. This is from Microsoft. And we just store it not on Hadoop nodes anymore, but in the data lake storage. And then we process data flexibly with Spark, like in the Databricks or stuff. And then we may download it someplace else and you do things with it. So basically the first idea there was just replicate the Hadoop idea to the cloud. No relational database in the picture, okay? But also here, also in the cloud, this thing is there. You want the power of SQL sooner or later to really work with structured data. So what you need is an RDBMS integration also in the cloud on a data lake. And this is how Oracle sees that. I mean, there are many pictures of Oracle. This is one of them where basically you see stuff is coming in, all sorts of files, then you put it into a data lake. And then the idea is to use a database or an Oracle database in the Oracle cloud, and most likely an autonomous database for all the reasons that you would use an autonomous database for, performance and low maintenance and whatever, to analyze that data from the data lake and to provide it to consumers. And also you could basically produce files for your data lake, which we see on the bottom here, from the autonomous database. So basically dump stuff out. Okay, but in order to do this, you cannot access an object storage in a data lake like you access a file on a file system, which was the very old way of doing it, or like you access an HDFS file system. This is completely unique, completely different implementations of APIs and stuff. And so you have to find a way how to do that and program the means to do that and provide them. And that's what Oracle also did. Right? They saw the need for efficient data lake interface from and to the relational database management systems. And they gave us, again, external tables to the rescue. So external tables were again enhanced and extended, not only to be able to talk to the Oracle object storage API, but to talk to several clouds. So now you can have your data lake on the Azure cloud, for example, or an Amazon S3, and you can run queries directly against it through the autonomous database by means of external tables. And of course, you can have your data lake on the Oracle object store also, that works, with the complete security integration and everything that you need. And we'll see that in a demo. And of course, they took everything with them that they already had implemented for file systems and for Hadoop clusters, like the partitioned and sub-partitioned external tables, and also, which is a very neat feature of Oracle, hybrid tables, as they call them. Basically a partitioned table where you can define part of the partitions being inside the database for fast data that you have in access very often, and that you are willing to pay the more costly database storage for, and partitions with colder data outside on a other storage layer. In the case of the cloud, the object storage. So that's basically what Oracle did, basically saying we're extending, we're going forward on that path with the technology that we have and open it up to a data lake in the cloud on object storage in 3 different clouds. And that's now where the fun part starts, because we're trying to do a real demo with those five points. We'll see how much time we have to go through there. Let me leave this. And now, first of all, let's have a look at my browser here. This is the Oracle Cloud. I'm on a pod in Frankfurt right now. So the first thing that you got to do in order to do an external table from the Oracle database to object storage, and I'll take the Oracle object storage now in the cloud, is, you have to have an autonomous database, and you have to have a bucket in the Oracle object storage, of course, but what you also need is a credential. You have to define credentials for the database such that the database knows where to go and knows how to authenticate itself in the cloud on the object storage should go. And to do that, you basically, for the Oracle Cloud, you have to generate an authentication token. And you do that by going to the identity service. Well, let me just re-sign in. This is, of course, always what we do. That things time out once we give a presentation. But yeah, that's why we love demos, right? Nothing works as planned. Okay, so again, identity, users. Still loading. And now I take a user, and then I have here this thing, authentication tokens. And then I can generate a token. And the token, that's just a string, right? And I can describe it like with something, my token, and I say generate token. Now the thing is, it's very important what you can read here. Copy this token for your records. It will not be shown again. So whenever you hit close, this token can't be reproduced. Then only you have it, and you can give it to people. If you lose it, you have to make a new one and have to re-register everything with that new token, basically. So I can show you. It's really just a string, right? And I can make a copy. I can store it, and whatnot. This is important. You do it. You make a token. Then, of course, next thing, we need a storage, an object storage. We need a data lake, basically. So I go to object storage, and here is a bucket, Aces at Home. And in the bucket, I have already quite a number of CSV files with altogether just 300K rows in all of these files, and those we are going to use. And then, of course, you also need an autonomous data warehouse. And here I have my autonomous data warehouse, Aces at Home, just one core, and the minimum amount of storage, since I'll be working on my little data lake in my bucket exclusively. All right, once we have that, and once we have downloaded the wallet for this instance of the autonomous database, when I've downloaded the wallet, now we go to the SQL developer. I've downloaded it, and I made a connection with that wallet, like we do with the autonomous data warehouse. And then I can connect. I'm already connected here, Aces at Home, and I can work. And now I can see, okay, I got this. I already had credentials. That's why I don't use the create credential, but the update credential methods, but I have to update it with a new value. That's the value from the token that I'm using. I'll change it later on, so you don't have to write it down. It's not going to help. And then I can basically do the update, and everything is fine. Then what I did is I created, this is used to create those 300K of test data. And then I exported that test data with the SQL developer and uploaded it in my bucket. Okay, right. And now I can start creating external tables against this bucket with those CSV files. It's basically like a staging area for me now. So I can make a simple external table, nothing fancy, which I will do, and I will also gather statistics on it, which basically means that the Oracle database not only creates the metadata, but also samples those files and starts gathering statistics. So the next time we go there, we're not going blind and guessing or an execution strategy, but there is already statistic to support finding a good explain plan. Okay, and now I can basically look at an explain plan for data, which is between the 10th of January sales data and the 10th of February. And when I look at the explain plan, I see there is an external table accessed full. And yeah, there should be a few 54,000 rows should be coming back. That's basically because we gathered statistics, right? And of course, I can also run this and I will get the data. And this is really, I mean, I did not install any infrastructure. I just clicked together in the cloud. I need a bucket and I uploaded a few files and I made myself an autonomous database. I made myself this authentication token and off I go. So it's really great and it's fast, right? So some things of course don't work. I cannot insert. If I try to insert myself, this operation is not supported because that's immutable storage, object storage. So I cannot insert into existing files basically. I cannot add a primary key or keys on this, on these external tables. And I also cannot add an index on the simple external table against the object store. Okay. Next thing that we want to look at is partitioned external tables. I can also define partitioned external tables, which I do here. And let me start this. Also then gathering statistics. And what you see here, I have one partition P1, which consists of 2 files. And my other partitions, just to have it easy, consist of 1 file each, right? But you can just see I can have several files adding up to a partition. Now, oops, if I now again do the explain plan for give me the data between 10th of January and 10th of February, and I look at the plan, now I can see it's just like if it was in the database. I get a full scan, of course, of the files, but partition 1 and 2. So it will basically just scan through these 3 files, the 2 in the first partition and the 1 in the second partition. So I'm going to read much more data, much less, of course, data, right? That is cool, isn't it? And something that I can also do is I can start a validation procedure here that would then really go through all of the files and find records that it would reject when I would want to, when I would basically load it and use the data. So I can check the data quality with respect to my definition beforehand. Okay. And that's basically what I can do here is say, okay, look at the first 1,000 rows in my case. And once it's done, I can look in this user load operation view, and it'll tell me, okay, I did that 1443, and there is a log file and a bad file. That really looks pretty much like the good old SQL loader that produces log and bad files. And I can see, I can, for example, look here at 3.9 at the log, validate 3.9, and then I see what it did. There are 7 files, and did this validation run. So this really looks like if it was the good old SQL loader or an external table inside the database. Okay, but now let's get to the next part of the demo. That's hybrid external tables. That's now basically an external table that has internal partitions. So basically I take my 6 partitions that I already had with my sales data from the first half year, and I'm already providing partitions for the next 6 months that should be internally now. So because I want 6 months of data being in the database for fast access, for hot data, basically. Now I created that. Now I have to generate this half a year of sales data. I'm just going to fake it right now, right? So that takes a few seconds to compute those 300,000 more rows for the next 6 months. And then we'll also do some statistics on top of that. And once it's done, I want to show you how the plans look like, how the database now accesses both the database files, the data in the database files, as well as the data on the object storage, on the data lake. And also, we want to see that and how partition pruning works. So now the data is done. Now we do a little, we do the stats quickly. And here we go. Now, if I now go and say, do the explain plan again for the data from January and February, then we'll see, or let me see what it does. It does nothing in the storage. Sorry, it accesses. Let me just see. I'm a bit confused right now. Let's just do for the comparison with the data that is inside the database. I'm not sure whether I ran that correctly. No, that's the same. It's the same thing. Let me just have a little. That's now the effect of the demonstration. I'm not seeing right now where the problem lies, because it just gives me the same plan, even though it doesn't do the partition pruning right now, and I don't have a clue why. We'll see. Let's go on, and we'll see whether it works then for the other parts. Well, that's the statistics thing, I guess. Don't know why. Anyway. Just give me one more second. Yeah, I think the problem was with me. How did that? Here now you see we are just going in. We're just taking data from the last partition on the object store and from the first partition in the database, and we just go through these two partitions. And if we run it, now we get basically really data from the files together. This is for June, that's from the files. And if I sort it the other way, this is data from the partitions from the database itself. And of course, I can also aggregate on those and all of these kinds of things. Now we see the data per month, the amounts added together. That's cool. And the counts added together to 600,000. So we got it from the files and the partitions. And what I see, the last thing that I want to show you quickly is you can do indexing on those hybrid tables. So you can basically now say the hot data is in the database, and I want to go to that quickly. But and it's okay to scan those files if anybody wants to look back in the past. So now I create an index on the table and say it should be a partial index. So basically only computed on the partitions where you can compute it, which would be the internal ones, okay? And now, when I now do an explain plan for a specific ID, I want to go to an ID and I index the IDs, then what we get is an explain plan that will go Oh, that won't go on the index, unfortunately. This is really strange. Did that this morning. Oh, this is really messing with me right now. But what it should do was to give us a plan that would use the index for looking for that one ID, and on the partitions that are index access on the partitions in the database, and then no, it's not using the index now. I'm sorry, guys. Don't know why it does that now. Not does that, but hey, what can we do? Basically, due to time constraints, I will skip another part. What I wanted to show you is how you can basically, but I will start the first thing and then just go back to the, what you can do is offload data. Now, once in our hybrid example, I had hot data in partitions inside the database and cold data on the object store in files, right? And I was able to this integration to query it all together. Now, what I can do is I can export and dump data on the object store from partitions, for example, like I did here. And then when I go to the object store, hopefully this hasn't expired yet. Yes, it hasn't, we're lucky. Now I have these dump files that I just created. You remember in the beginning, they weren't there. I have these dump files of my partitions basically on the object store. And now I can basically, if I have a hybrid table, I can drop the partition that where the hot data was in up until now, and have it basically create a new partition definition for an external table definition on that dump file, and parsing dump files is of course faster than CSV files. And so this way you can basically now offload old data on the much cheaper object storage, but still have it in reach, which is another use case, right? So, but we're not going to look into that now. It just works the same as the other demo, only on dump files. So now let's get back to our demonstration. It's more or less what we saw. I'm sorry that the explains plans didn't work the way they should. This was a statistics problem, mostly, I would say. But hey, that's what we are doing demonstrations for, that you have also a laugh every now and then. So what kind of use cases do I see for this tight integration? Well, one, of course, which is really obvious, is use the data lake as a persistent staging layer, right? From the data puddle in the beginning, from the small file system where you have to move stuff off or delete files or stuff. No, you can mostly keep all your files in the data lake. That's what it's for. And then you can basically reload your data warehouse from scratch if you want to. Only, of course, you have to think about data formats change over time, and those files have not changed over time unless you have rewritten them to a new format. That's the challenge there. So persistent staging layer for cloud data warehouse, great stuff. Then the other one is provide a SQL data hub on the data lake. So as I said before, many people want SQL access to data in the data lake. And doing the security also on an object storage and stuff, it's not that easy for most people. So it's much easier to provide a set of external tables on all of your data that you get into the data lake that you can, I mean, pictures, not easy, but even JSON, Avro, Parquet, of all of these kinds of file types, you can basically generate an external table SQL interface on your data lake. And now you can use Oracle security with VPD, with masking, whatever you want to do, to provide the data in a secure fashion to user groups through the technologies that you already use today to secure your data in the database. So SQL Data Hub, great use case. And then what I was just talking about, data offloading, getting data out into dump files, so to save precious and more expensive Exadata storage space in the autonomous data warehouse, but still have it in reach and query it just like if it was still in the database. That's a cool one. And I would say, if you now think about the possibilities, it's an open, long road. You can come up with new use cases, I guess, yourself. There are plenty. Okay, and finally, all of this gives us, I guess, savings. Just the offloading, for example, a terabyte of autonomous data warehouse space is much more costly than a terabyte of object store. It's really simple to use. And the scalability of the storage space is more or less endless. That's what the hyperscalers tell us about object storage. You can control the access, have easy access and very controlled access. You can be very agile through automating lots of stuff like creating the external tables and recreating them with new partitions and these kinds of stuff that can all be automated through scripting. And then of course the performance is really good. It's really good as far, because the networking today in those data centers of the hyperscalers is so fast. And so you have a very versatile architecture where you can do lots of different use cases. And with that, I'm there. My conclusions, pretty much on time. I'd say the data lake concept, and we've seen how it has developed from a pure file system landing zone or something through the Hadoop era and data lake on premises to the cloud. Data lake and cloud are natural matches. That's basically where the data lake really works, much better than on premises on a Hadoop platform. My personal opinion, of course. And as we have seen with the extensions to the external table concept and everything that Oracle did in the Oracle world, data warehousing and data lakes play very well together. So you can really have the advantages of both of them, the best of both worlds, as one says. And of course, the key concept for having that are the external tables that Oracle provides, with all the partitioning, with everything that you get there, with partial indexing and all these kinds of things, okay? So those open up new use cases, those provide secure and performance SQL access to the data lake and the best of both worlds. And if you think about, so my recommendation is have a close look at the possibilities of the way how to use that for your use cases, and improve your data warehouse architecture, especially if you go into the cloud, but also if you're still on premises, because this hybrid stuff and partition stuff, that's also there on premises. So even with some more features currently, look at it and use it wisely and improve your data warehouse architecture, and your journey to the cloud or on premises with the data lake will be just great, I would say. Yeah, and with that, I'm basically done with the presentation part. I guess I should look into the questions and answers.
Yes, there are a few questions waiting for you.
Yeah, okay. So is it possible to create external tables on object storage in on-prem databases? That's a good one. I haven't tried it that way, but it should work. If you're no, you need the DBMS cloud package to do that, right? So if you adjust, maybe I'll just can we no, so I don't want to stop sharing. So if you see my screen, everything is done through this DBMS cloud package. And I have to admit, which is a shame, I never looked whether this DBMS cloud package is in 18C or 19C on premises available. But that's basically the thing. You cannot write a create external table, blah, blah, Oracle loader or whatever, like we are used to do on premises. That's also why you can't easily do an alter table at partition. Or everything has to go through this DBMS cloud package that does all the magic with the authentication and storing the metadata for these kinds of things in the background. So I have to say, I cannot answer the question. I don't know, really. But I suspect it's not, that it won't work. You should look whether this package is there. Okay, next one. Can we use external table pre-processing on autonomous DB, like unzip compressed CSV file? Not to my knowledge, again, because this DBMS cloud package does not allow to provide a clause for pre-processing. But you can there is a possibility to tell in the format options to tell the cloud package in the definition phase that the files are, for example, compressed. I think it doesn't do zip, but it can do gzip and bzip and whatever. So, and then there is pre-processing there. So you can basically zip all of those files with gzip, for example, and have them so even save even more money on the already cheap object storage, and then have the database do that. But more complex pre-processing is not possible because you cannot define it. There's no way to define it. Yes, you have to do, the next question is, do we have to do partitioning manually every time we add up CSV files followed by others by gather stats? Well, the gather stats is of course optional. I just did that because I could and because I want always the optimizer to have as much knowledge about what he has to work with or it has to work with as possible. Yeah, right. Currently, you have to do that manually on premises, and that is something that I've tried out several times. On premises, you can use wildcards in the file names. And apparently it didn't work well in 18C, but it works in 19C. So if you just add a new file and you have a naming scheme where this new file already belongs to with a wildcard to a partition definition with a wildcard, then it will be automatically added and scanned in that partition, right? Not so in the cloud. There, these wildcards don't work for me, so you have to add every file manually. And of course, you also have to tell, even if you use wildcards in the definition, where the files go to, because the database can't know from a file that it hasn't seen so far, that it hasn't ingested and controlled, it hasn't inserted the data in its own vessel, basically, of a database file. It can't know where it belongs to. You have to tell it. How can I automate the upload of CSV files into the object storage? Also, is there any mechanism to validate the upload process? Well, this is now a cloud, an OCI question and not a database question, really. Of course, you can automate the process. I mean, what we do with customers is basically, because mostly their OLTP data is still being generated on premises and not in the cloud. So we have a process on premises that takes files from a landing zone and pushes them script-based into the cloud. So you can use the REST APIs of the cloud to open up a connection, go to a bucket and store a file there. And of course, you can also run from on-premises. You then can run a SQL script through SQL.cl or SQL Developer or SQL Plus script that connects then to the autonomous database and generates an external table automatically or whatnot, right? Or extends the definition of an external table. So that's what I would do, would basically grab the file in delivery and then run scripting to put it onto the data lake where it belongs to, and then also tell the database that it's there. So yes, I would definitely, of course, automate these kind of processes, and through scripting and APIs, that's not a problem. Now I said that yes, then I get the question, did you just say that we can create external table accessing JSON file on the object storage? I don't know about all the formats that you can do, but you can of course go against the JSON file on the object storage and either read it you can read it as a JSON type into the database and then run SQL against it on Oracle. But you can also, besides JSON, you can also read Parquet files, Avro files. So I didn't show that, but you can read also files that have the schema definition in their format, right? So you can basically create an external table where you say, read these Avro files and derive the columns and data types from the schema that you find in those files, right? So that's then even Oracle does the parsing and does the column list and data types for you. So that's possible, and also with JSON. these kinds of things. Yeah, and I guess with that, that was the last question that was open. Yeah, many thanks for being with me for this almost an hour. It's been fun for me. I hope it has been fun for you, and not only the little hiccups in the demo, but just all of the content. Thanks again, Gianni and Christian and everybody organizing this. And with that, back to you guys.